Alrighty, we see more and more people settling in. Thank you again for joining us today for Raise Your Voice Part 2. I'm Chloe, and I'm here with Simon Prickett.
Good morning.
I am the marketing manager here at Zesty.io.
And I'm a senior software developer at Zesty, working on building our content management platform.
And one of the biggest questions that we've gotten since we've started this series is, why are we doing this? Seeing as how voice technology continues to rise to the forefront of consumer electronics and consumer devices, we've taken it upon ourselves to learn more about the different voice channels, learn more about how we can build out functionality in our platforms to continue to provide value to the enterprises who are looking to syndicate their content. A little bit of background real quick on Zesty.io. Zesty is a SaaS enterprise web content management platform. We've simplified the delivery of content across websites, mobile apps, web apps, and now in that portfolio is voice devices as well, smart TVs, you name it. And to cover what we're going to be looking at today, first I'm going to do a recap very briefly on the previous webinar that we did, talking about how marketing teams can implement voice into their strategy, because if there is no strategy behind it, there is no sense in building all the cool things that we're going to build today. Then we're going to look at the benefits of having one content repository, and then I'll turn it over to Simon to walk through the Alexa example that we have for you guys today. Go through step by step, looking at building the skill, connecting it to Zesty.io as a content repository, and then we'll wrap up with questions and answers. So again, very quickly, main use cases for a voice application typically fall under one of these four categories: informational, conversational, newsworthy, or fun content. If you're interested in learning more about this, we did a full webinar. You will have access to the link to replay that after this webinar. And a few things that you can do today, first of which being adding schema from schema.org to your website to be able to answer simple questions such as, what are your store hours? Is there X on the menu? Things like that. Building out an Alexa skill, which is what we're going to be focusing on today. Using nameless invocation once that skill is built in order to further continue reaching new audiences who haven't yet installed your skill on their device. And then finally, making sure that your customers know that you have a voice device, or voice abilities rather, so that they can actually use it and spread the word as well. So why does this all matter? Again, very brief recap. We're looking at trends from 2016 all the way up to today. You can see clearly that between Amazon Alexa, Google Home, Apple HomePod, and others such as Samsung smart devices are constantly vying for the market shift. So the situation is such that as different players start to enter the voice device market, it's going to be very difficult for IT to keep up with building different channels for marketing teams to be able to have an Alexa skill, functionality on Google Home, Google Assistant, functionality in Apple HomePod, and others. And Simon, you looked into this earlier this week. Amazon Alexa is actually releasing now a car echo, right?
Yeah, so as well as the voice channel going into more places, so the car as well as the home, that voice channel itself has other sub-channels within it. So just looking at Alexa, there's a companion app that displays visual content. There's devices such as the Echo Show that have a big screen that can display content. And only this week, Amazon's come out with more rendering options for those screens. So this is, even within one product, there's multi-channel in here.
Right, which that means it's going to become exponentially more difficult to manage all of these different channels. Which brings us to the main point of the benefits of having one content repository. I think probably the most obvious is that it empowers your marketing team and your IT team for headless functionality. Being able to separate content from presentation so that content can be deployed anywhere regardless of a screen or regardless of device, with the next point, minimal IT friction. Having one content repository makes it much easier for IT to be able to build and continue to iterate on new channels without frustrating the marketing team and vice versa. And finally, cost predictability. Having all of that content in one repository makes it much easier for businesses to be able to scale and continue to have a more predictable monthly cost depending on their service. So that's enough of the marketing side, enough of an introduction. I'm going to turn it over to Simon, who has a really exciting demonstration for you guys today.
Okay, so what we're going to do today is look at actually building out an Alexa skill and what that actually means, what the steps are, and where the Zesty.io product can add value to that. So what we're going to try and achieve is we want to build an Alexa skill using the Zesty.io content management platform. The responsibility of that is going to be to store the content, the text, also images, because as we said, it's not only a voice platform, there's also screens involved, both with the companion app and the show device. To help us build that, Amazon provides a Skills Kit SDK for a variety of languages. It's available in Java, Python, and Node.js. We've gone ahead and picked Node.js on the basis of its JavaScript. And if you're running a development team and you're already maintaining and building a website, chances are you have some JavaScript developers whose skills could be useful here without further training. And once we've actually built some code that interacts with both Zesty and Alexa, we need somewhere to run it. So again, we've chosen Amazon's Lambda serverless functions runtime here because it supports Node.js. It has an easy connection to the Alexa SDK, but it's not the only option. We could have gone with Azure functions from Microsoft, or we could have gone with Google Cloud, or any application server that we can expose to the internet as a URL. So anything we can run a website on, we could also run this on. So looking at the architecture of what we need to build here, the way Alexa skills work, sort of starting at the left with the user there, is the user would issue a command. So they would say something like, open my business skill, or ask my business, what are your hours for today? That command goes through the Echo device that they have in front of them, and it's sent to the Amazon Service Platform, which is a cloud service. The job of the Amazon Service Platform is to break down the speech and tokenize it and work out what the user's intent was. So what did the user want to do? And what supplementary information did they provide as context to that? So the intent might be my business and what are the hours, and supplementary information might be Monday, if the question was, tell me what are the hours for your business on Monday. That information is then passed to the custom skill code, so our Node.js AWS Lambda function in this case, and it's passed as a regular JSON document. So by this point, the speech aspect has gone away, and we're now basically processing a data request. That'll receive information about what the context was and what the intent was, and then it's entirely on the developer to figure out how to resolve that, get content or a response from wherever they're going to get it. In this case, we're going to use Zesty, and then return that response back to the Alexa platform, again as a JSON document, which the Alexa platform will then speak out through the device, and also optionally render out as cards over there on the show screen if you have the show device, or on your phone if you have the companion app for iOS or Android. So over there on the right, the role for Zesty in this case is to receive requests from our Node.js code. Again, with context about, in this case, we've asked for like opening hours for Monday for my business. So there needs to be something on Zesty that goes into Zesty's content model and says, okay, let's get something for opening hours for Monday, form a JSON document up from that, and return it to the node code that can then send it back up the chain. So Zesty here is the content repository, and it's also rendering, but instead of rendering a traditional web page, it's going to render a JSON document. So you could think of it as a headless API in this case. So what have we actually built? We didn't build a business opening hours skill. We built something a little more entertaining and zesty, which we call Zesty Scopes. So Zesty Scopes is a skill that knows a few things about horoscopes. So you can ask it questions about what is the horoscope for a given star sign. It knows things about people who are of each star sign. So what traits, what are people like? And it knows things about when those star signs start and end. So what time of year are those people born? It's a multi-channel experience. So whilst we're talking voice here today, we also built a website off of the same data and the same data models in Zesty and the same templating language that we'll briefly show. So this is a multi-channel experience with Zesty powering both, such that if the content were to be changed in the CMS, it would be reflected in both channels immediately. We're also supporting the Alexa show in a small way. We are using some of the visual cards, and we're offering images to users who have the screen, as opposed to just voice to those who don't. So what we'll do is we'll switch over to take a look at that. So here we have the very, very basic website that we built for this. We didn't spend much time on this because it's not the point of the webinar, but we have content here, we have images, we have star signs, we have dates, we have traits of the people who were born under those star signs, and we have a couple of readings. So we have this week's reading, and you can click here and it'll go away to the back end and load last week's reading. This is a regular website. We also have in here the Alexa skills kit, and we have the skill that we've been building. For now, we'll just go straight to test and take a look at how that works. So the way this works is the skill's called Zesty Scopes. So we say, hey, open Zesty Scopes.
You want to make it full screen so that we can see?
Yeah.
Thanks.
Welcome to the Zesty Scopes Alexa skill. You can ask me questions about horoscopes and star signs. For example, ask what's this week's reading for Leo, or which is the sign of the bull.
So what we've got here is, you can see we told Alexa open Zesty Scopes. I'm typing to Alexa here because this is the developer console, but the speech recognition works the same. You can click the microphone and talk to it. So we told it open Zesty Scopes. It comes back with a sort of welcoming monologue. It tells us what Zesty Scopes can do. And then we can ask it some more questions and have a conversation with it. So we can basically ask it, which is the sign, the bull. So it knows about animals and mascots
Taurus
for
is
signs.
the sign which has the bull as its symbol.
So it can tell us that Taurus is the sign for that. What you see here is the blue area up here is the spoken text. So it literally said Taurus is the sign that has the bull as its symbol. If you have an echo show, just repeating that isn't particularly valuable because you have all of this other real estate to add information on. So we've gone ahead and rendered this slightly differently in the CMS content. So here we have a more approach that's more suited to reading than speaking, and we've added some extra detail. So we've added the start and end dates for Taurus. So the spoken channel, it's a quick question. It gets us a quick and sort of pithy to the point response. The visual channel is a slightly longer response. And then if you have the echo spot, you get the same response minus the picture, and you'd scroll that. So how this talks to Zesty, and we'll come to this in detail later, is through JSON. So our code made a request once it had received a request from Amazon. Amazon told us what we needed to get. We needed to get something about star sign mascots for the star sign Taurus. So our code received that. It formed up a backend request to Zesty, and Zesty responded with this document. We'll cover how we got there as we go through the webinar. So the first thing that we need to build to have a skill that works is what's called a voice interaction model. So this is an Amazon thing that sits on Amazon servers, and it has 4 components to it. The first one being the invocation name, which is what we call our skill. That has to be unique across the whole of the Alexa platform. So when we say, Alexa, open Zesty scopes, in our case, it knows that that's us. Once we've got an invocation and we're able to direct requests at our skill, we then need a set of what's called intents, which are actions that the skill can perform. So for our star sign example, intents might be things like, I want to know what the horoscope reading is for something for a time period, or I want to know when people who have a certain star sign are born, what time of year, or I want to know what the animal or symbol associated with a star sign is, or what the star sign associated with an animal or symbol is. So each of those would be intents, but intents generally need a couple of other things. They need what's called utterances, which is a set of sample sentences or phrases that might trigger that intent. So what you can see over to the left is we've got a whole selection of sentences in there that all boil down to the go get the mascot or the animal for a given star sign. So we could ask it questions like, what sign symbol is a bull? Or the twins are the symbol for which star sign? And we don't need a complete list of sentences here. We just need a good representative sample, because Amazon's AI model will match this in a fuzzy match to what the user said. And if it's a good enough match, it will fire that intent. So having a good selection of samples is good, because it allows you to make sure that you catch the most common phrases, but you don't have to be absolutely complete here, because Amazon will fuzzy guess quite a lot of options around there. So once we have intents and utterances and invocation name, we still need to know, in some cases, some variables about that invocation. So if I say, ask Zesty scopes, what is the animal associated with Taurus, or ask Zesty scopes, which star sign has a bull as its symbol, then we need to tell the Alexa platform that we're interested in the bull in that case, because that's a variable that we need to know about to go get the right content from the back end. So wherever you see the curly braces mascot in the example off to the left, that's us telling Amazon that there's a word there that we want to capture and we want to know what it is. Those slots or variables, we have to provide a list of possibilities for. So we call those star sign mascots. And we have a list elsewhere in the voice interface that tells us what all of those are. We'll look at that in a second. So once we've built a model like this, we can either build it as a JSON file, or we can actually build it interactively on Amazon's developer portal. And once we've done that, Amazon then goes away and parses that model and starts to build a sort of AI model for matching phrases that are associated with each intent. So we'll take a quick look at that. If we have a look here, we were in the test tab here on Amazon. If we go to the build tab, what we can see down the side is we have our model loaded. So if we pick that intent that we were just looking at, the one that tells us which star sign is associated with an animal or a symbol. We can see these are the utterances here that we loaded. Here's some of them, and you can paginate through them. Where it's got mascot highlighted here, that's a slot, which is a variable. So we have a slot here called mascot. Slots have types, so we're saying we expect to find a star sign mascot in here. And what we can see by clicking here is we've provided values for what all of those will be. So all of the star sign mascots down here are all of the ones that you can have. So the fish, the water bearer, the goat, the archer, etc. Again, we don't expect users to necessarily 100% know what we're looking for here, nor should they have to. So over to the right, we can provide synonyms here. So for example, they could ask Zesty Scopes, what is the sign for the archer? And we would return the correct information from the CMS. But they could also ask us, they might not know archer, they might just say, what's the sign for the bow or the bow and arrow or the shooting guy or so on. So we can put synonyms in here. These are important, again, because it reduces user frustration. So the more synonyms you can think of, the more chance the user is going to get their question answered in the right context at the first time without having to go into a sort of guessing game with the skill and trying to figure out, well, I don't know what it wants. So once we have a voice interaction model, that kind of covers this part of the architecture. So the voice interaction model contains the intents, which are the voice commands. It lives on the Alexa service platform. And when it's fully baked, it also knows where to send those intents once it's heard them. So to our Lambda code, which we'll come to later. So if we've now defined a set of possibilities, so intents and slots for our skill, we kind of know all of the things that the skill needs to be able to talk about. So we've got in our skill, we have star signs, which is Taurus, Virgo, etc., and information specific to those. We have horoscopes, which are readings or predictions for each of those star signs. We have traits, which is a set of behaviors or character traits of people that have that star sign. And then we also have a fourth category that's not directly to do with the content matter, but prompts for things like, what if Alexa doesn't understand? What do we say there? Or that initial opening prompt when they open the skill, what do we come back with? So you can think of prompts as sort of like guiding or menu items, and everything else in here is the content. So in this example, we're obviously using the Zesty.io CMS as the content store for this. So we need to build out models for each of these things in Zesty. So this is the Zesty.io interface for doing that. So we're in the schemas area of that because we're building a schema in the CMS against which marketers can then create content, and developers and those producing the website or the endpoints, the JSON in our case, then know what each content type's fields are, what the type of that field is, and whether it's required or not, etc. So we're essentially building out a set of rules for how we manage the content. So we're looking at star signs here. We wanted each of our star signs to have a name, and that's required because you need that. And it's a text field. And then we wanted them to have a mascot, which is another text field. So the bull for Taurus, for example. We want an image associated with each of them because we've got a nice set of images for the various symbols. And again, even though this is a voice webinar, it's got visual components to it, both in the companion apps and the website that we built. And then we wanted a start and an end date for when that star sign's time of the year is. Similarly, we have oops, I'm gonna have to log in again. And two-factor authenticate myself. We're using the Authy authentication, so I'm actually authenticating from my phone. I don't have to type. And we're back. So we also have a traits model that records for each star sign what the traits of those are. And here the star sign isn't a text item, it's a link. So it's a relationship to one of those other content models we've created. So we're creating a relational content model here where we have star signs that are linked to star sign traits, and similarly will be linked to horoscopes and the other data items we have. Then specifically for Alexa, we have this content collection of prompts where we just have a key name and key value approach. So a prompt might be key name welcome, and the key value would be whatever message we want to speak to people when they first start the skill. So if we move over to the content tab here, we can actually see some of those. So here in Alexa prompts, we have actual content that somebody's able to edit and manage in the CMS. So I can open up the welcome message, for example. And this can be edited, versioned, and managed entirely in Zesty without writing any code. So should you want to change your skills welcome message, you can do so right here without going to a developer. And then we have content that's used across the web and the Alexa channel. So if I go to, for example, star signs here, we have all of the star signs. Each one has that image and the start date and the end date and the other things that we put in the content model. We also have up here the horoscopes, so we can go in and write a new horoscope, much like you would a new blog page. And if we were to hit publish on that, it would appear on the website and be available to the Alexa skill at the same time. So looking at where the content fits into the architecture, it's way over there on the right. So the person writing the content isn't really necessarily involved with the rest of the architecture and doesn't have to be. They're just writing content regardless of channel. And in this case, we're consuming it through Alexa, but we're also consuming it through that website we built. So the next stage, once we've got the content into the CMS, is how do we get it out of the CMS and into something that we can work with? So normally, traditionally with content management systems, you do that by building a website. So you would build a series of HTML templates, and maybe the CMS has a templating language, and you would use that to build those, and then you would serve them as a website, and your templates would have placeholders for the content. It's exactly the same as what we're going to look at doing here, except rather than serving a web page, we're going to serve a JSON document in what Zesty calls an endpoint. So here we're essentially creating a sort of mini API on the fly for our content, and we're in control of what that looks like. The way we do that is we use Zesty's built-in templating language, which is called Parsley. Everywhere on the screen that you see the double curly braces, we call them HUDs, you'll see a placeholder for some content. And the way it works is it's the content type name dot the field name from our model. So sign dot name would be Scorpio, for example. Sign dot mascot would be the scorpion. And what we're building up here is a JSON document that contains, specifically for Alexa, a speech response, which is the text that we'll have spoken out, and then some fields for the visual card. So the title for the card, the image for the card, which would be the URL of that image from the CMS, and then card content, where we have some plain text English in there that's different from the speech response. So this is one of the ways that we're able to use the CMS to vary up within one channel Alexa what the content looks like inside the different presentations in that channel. So the speech response is pretty terse. The card response has that extra date information that we didn't put in the speech. We can create these templates either inside Zesty's browser editor, so you can do that online, or we're currently just in the process of alpha releasing a plugin for the Atom browser that you see in the screenshot there. So you can just edit these in your favorite browser, hit save, and they'll be synchronized back to the CMS. We'll just quickly look at that in Zesty. So in the more traditional editor, I have sort of color coding and context completion help here to write this, because Zesty knows what sign is. It's one of our content models. It knows what the fields are. And what we're saying here is essentially go find the sign that matches whatever we were given in a request parameter called sign, so Scorpio or Taurus or whatever, and then populate the JSON document with information from that. That request parameter is going to come from Alexa, and it's going to be one of the slot values that it got from the voice model. So if we hit this intent, that'll come with a slot value for what sign are they asking about, and we'll pass it in here. Zesty will resolve that, send back the right content, and then we'll have to parcel that up for Alexa. So where does that live in the architecture? So the custom endpoints that we just looked at, the JSON document that we build in Zesty and the templating, that's kind of the link between our custom code skill that we'll look at next in Node.js and the CMS. So on one hand, Amazon sends an intent request to our code saying, hey, they want to know about the mascot for Taurus. Our custom skill then resolves that by hitting a URL on Zesty that says, hey, render that template in the context of Taurus and give me back the JSON response. So in order to connect these two things together, so to connect Zesty with the Amazon platform, we need a small amount of glue code, whose job is basically to receive messages from Amazon, send requests to Zesty, parse out the responses, and push them back into responses back to Amazon, which will then handle speaking those responses and rendering the cards. The good news here is that Amazon provides a lot of off-the-shelf support for the dealing with the Amazon platform side of the house. They call that the Alexa Skills Kit SDK. It saves you a lot of writing boilerplate stuff for parsing out their API requests and for creating their responses, and it gives you much higher level abstractions to work with. It's also a very common pattern to use in the Alexa world. So if one developer's built one of these using this SDK, the only thing they need to know to build another one is essentially the difference in where the data's coming from in the back end. So in our case, how to talk to Zesty. This SDK is available for a selection of languages from Amazon. So again, we chose Node.js because the likelihood is you'll have JavaScript developers in your organization. It's also available for Python or Java. They have exactly the same functionality, so you can choose the language that you prefer to work with. And all you need is basically some basic skills to make a network request to Zesty, look at what you got back, and push that into a response for Amazon. So we'll take a look at how one of these intents is resolved inside Node.js. So let's make this a little larger. So the way that this works is there's stuff in the Amazon SDK that essentially matches names in the voice interaction interface that we created earlier to function names in the code. So if the user says, hey, Zesty Scopes, what's the animal for Taurus? The voice interaction model is going to decode that to mascot for star sign intent and it's going to have a slot called mascot, and the value it's going to pass us is Taurus. And then it's going to call this guy, mascot for star sign intent handler, and that's going to basically handle the request inside the handle function here. And the way that we handle that request is we pull out the value of the slot that we were given. So we pull out the slot mascot from the input message from Amazon. So that's going to resolve to say Taurus. And then we simply use the popular Node.js request package, or we could use node fetch or anything else that can go fetch a URL. And we hit that endpoint that we created with Zesty, and we pass it in the parameter it's looking for, mascot and a value of Taurus. And then when we get the JSON document back from Zesty, we send that back to the Amazon SDK, and we use their response builder. It's extremely simple. It has a .speak. You put whatever you want spoken in there. So we're going to use the speech response from our JSON document. And then information about building the card, which is optional. So we've got an information about visual information to convey in this case. So we're going to send a card, and we're going to use the other fields from that JSON. So that card title, the card content being the longer explanation with the dates in it. And we send the image twice because they support 2 sizes of image. So we could even switch out the images depending on whether it's the spot or the show. So every time the user talks to Alexa and Alexa figures out this is the user's intent, it's going to hit our AWS Lambda function. It's going to run this piece of code here, which is then going to hit the Zesty CMS, get the latest version of whatever the piece of content is, render it with our templating language as JSON, bring it back here, and then we're going to put it in a response to Amazon, and everything goes back in the reverse direction. Amazon gets that response, forms up the speech on its servers for it, and blasts it out to Alexa. So this Lambda code kind of sits in this part of the architecture. It's the glue between the 2 platforms that we're using here. So if you think of the Alexa service platform as kind of a browser in this context, and you think of Zesty as kind of a database in this context, then the custom skill is the thing in the middle that understands how to respond to the browser, get the information out of the database, and respond with an appropriately formatted document, which in this case is JSON. Then it's Amazon's job to render that out to the voice in the form of a spoken response, and the Echo Show in a visual response, and the companion app in a slightly different visual response. So we've kind of looked at these 4 things independently. So we've got a content management system, we've got a piece of code that talks to the content management system, we've got a speech platform at Amazon, and we've got a voice interface. So we'll just quickly look at how we hook all of those together, which is back to the Alexa platform. So here we had our voice model. We said when we run this guy, or when Amazon runs this guy and it hears open Zesty scopes, it's going to figure out what intent's needed, and then it's going to send that intent somewhere to resolve it. So that somewhere is AWS Lambda. We can go down here to the endpoint here, and this is where we tell Amazon where to go every time they receive one of these. So we're using AWS Lambda because it's kind of the easy option here. There's no servers required, no setup. The cost of running it is extremely cheap. So we've pasted in our Lambda ARN, which is our unique Lambda ID for the bit of code that we deployed to Amazon. If we didn't want to do that, we could use the HTTPS tab here. So say you're an enterprise that hosts its own servers, or you don't use AWS, you use like Google Cloud or something. Amazon also allows you to run skill code anywhere that they can hit it on the internet, as long as it's an SSL URL. It's their only requirement. then if we look at where our code actually runs on Amazon Web Services, there's nothing special about this particularly. It's just an AWS Lambda function. The one thing that we did maybe differently from normal is we're using Lambda functions have to be triggered by something. So either the API gateway or AWS IoT product or other things like S3 buckets. In our case, we've chosen the Alexa Skills Kit trigger, which just basically tells Amazon this is going to be hit from Alexa and allow that to happen. So you can't hit this code from somewhere else. It doesn't have a public URL. Only the Alexa Skills Kit can touch it. And what we've done here to get our code here is we've taken the complete Node.js package, we've zipped it up, and we've just uploaded it into this Lambda skill and hit save. And then every time Alexa comes along and needs to invoke Zesty scopes, once it's worked out what the intent and the slots and the parameters were for that, it's going to call this cloud function or this Lambda function here and expect it to respond with something. So that function is then going to talk to Zesty, get the content, respond back to Amazon, and speech comes out. Sorry. So the other aspects to this is we've got a skill here that is currently in development. So it's not available. You can't add this to your own Alexa yet. But we can go ahead and publish this and get it reviewed by Amazon, which is something we'll do in future. So just a quick look at how you do that. It's a little bit like working with the Apple App Store. You have to provide some standard information about your skill, like what it does, what information it might require of the user, how to invoke it, some icons so that when you add it, those show in the companion app. And you can put it somewhere in essentially the skills store. So they have lifestyle astrology, which is great because that's what we're doing. And once we've filled that out, we can save that. The next step from that would then be certification. So as you can see, I need to fill out some of that information before Amazon would even let me go ahead and certify this. And once they do, they perform an automated test on the skill to try and, I guess, break it. And you get a report back from that. And then you can submit it, and they perform sort of black box testing on it that we don't know about. And you'll be live in the store if you pass that, or you'll get feedback and have to go through and fix a couple of things. So the go live process is relatively simple. In this case, because we've used AWS Lambda, that will scale infinitely if we get a lot of demand, if this skill becomes extremely popular. And then Zesty is also a SaaS platform, so your backend will scale according to the need for fetching the data. So in summary, what we've had a look at in various levels of detail is how we can use or benefit from a CMS platform that is both headless and provides a rich editing interface for marketers, but also a powerful templating language and the ability to build ad hoc APIs for developers. So we can take one set of content and we can use it across just saying we're going to do a website in Alexa. We've really got all of those channels. So we've got a website, we've got spoken Alexa, we've got the companion app, and we've got the screen on the show. Before we even consider adding another voice product like Google Assistant or another channel like, say, the Fire TV or Apple TV or something like that. But we have a toolkit here that can be used across all of these channels with consistent development practices and consistent content management practices. And there's still some work to do to make the content work well across these channels. So having conversational style content that we talked about in the prior webinar is good because it works well across speech, it works well on a television, and it does a reasonable job in a website. So you can get into a trap of having to write the content however many times for as many channels as you have, or you can take a step back and look at how you model and what your tone of voice and so forth is for that content, and try and eliminate that duplication by having something that's appropriate across everything. And also, as you continue to grow channels here, there's very little infrastructure to manage. So if you added something for, say, Fire TV, that will be just another endpoint on Zesty with no coding required. If you were to add Google Home, that will be a second equivalent of the Lambda function, which you could host anywhere, and maybe the same endpoints on Zesty if you want to use the same content as Alexa. So everything scales, there's nothing to install, so developers can get on with building the experience and marketers can get on with writing the content.
So with that being said, we have roughly 10 minutes left for questions and answers. We will give you a moment to type in any questions that you have. The first question, I'll act as the Vanna White today. The first question we have coming in is, could it connect to Google Home too? Simon?
Yes. Essentially, the Google Home is a different set of APIs, but the same concept. So what you need to change out would be your voice model would be different, because the voice model we looked at is Alexa specific. And the Lambda function that we have would also need to change because it's now going to talk to Google's platform and need to respond in their format. But if you've written the content correctly, then it should translate directly across, because you probably don't want to have voice content that specifically says Alexa in it, for example, because then you can't rehash it across channels. And you definitely want the sort of conversational style, but also a content model that maybe has slight summary versions of those in it too. Because with the Google Home, you get, you're actually integrating with the Google Assistant, which immediately puts you into Android and a chatbot type interface as well as the Google Home, so that there's many channels in there that you can't really avoid dealing with once you go there.
Awesome. The next question we have is a very interesting one. Are you able to, and if so, how, handle user personalization?
Yep. So let's take our star signs example. It would be kind of annoying in the real world if you want to check, if you obsessively check your reading light every Monday morning. You know, ask Zesty Scopes, what's the horoscope for Scorpio? It would be kind of good if Zesty Scopes knew that you were a Scorpio and you could just ask it, what's my horoscope this week? Then how you could manage that is, there's a couple of ways you can do that. The Alexa platform supports what's called account linking. So when the user installs the skill, you can configure it to request it is linked to, say, their Facebook or Amazon account or other platforms, or your own system if you're an enterprise that has, you know, say a shopping cart or something. And that will be handled in the Lambda code or wherever you want to run that code. And that would then link that user's Echo ID to their account there. And then your code will be able to pull values out of that and use it to personalize the experience. On a lighter level, we could also have the Lambda code. It basically runs a session like you do with a web browser with Alexa. We could store information in that session, like the user has asked for the Taurus horoscope. So let's assume they're a Taurus. So if we see a question without context, like, okay, what are my traits? Then we just substitute Taurus in for the missing value that we need to answer that question properly because we heard it earlier in the session.
Interesting. How quickly is the Zesty content updated to the voice devices? That's a great question.
Okay, yeah, that one came in from the Zesty developer channel. We do run a developer Slack channel to help folks using our platform, so thanks for that. How quickly is it updated to the voice devices? There's no caching in this system. We didn't build a cache in the node layer. So if you were to go ahead and edit something in Zesty and publish it, it would then be live, and it would be live to both the website. So say you published a new horoscope for this week, it would immediately appear there. And then the first time someone asks for it on the Alexa, it would appear there as well. So essentially immediately.
Awesome. We have two more questions that I want to make sure that we address. The first of which is, what's the possible scale? Are you able to reach 10, 100, 1,000 users?
So the good news here is all of the sort of front-end components, so the Amazon speech recognition, decoding to JSON requests, and in our case, because we chose AWS Lambda, they scale automatically, and that works both ways. So when no one's using it, we're not paying for servers. When lots of people are using it, we're using lots and lots of Cloud Function invocations with Lambda. But they only last the precise time that is needed to fulfill that request, which is milliseconds. So those aspects scale very well and are proven and sort of industry-wide. The Zesty platform itself also runs on the Google Cloud in the background, so we benefit from the scale of that, and we also have caching layers and a CDN in place. So if you haven't published a new bit of content, we can be re-rendering that from cache without any workload imposition.
Perfect. And a great transition from this question to the next one is, what sort of analytics do you have access to?
So I'm going to switch over to Amazon here. So Amazon provides you with, find this. Once the skill was live, Amazon will provide us with some analytics about what are people actually saying to invoke our skill, so we could tune our model a bit more. Session times, so how long do people spend with the skill before they just walk away and we're dropped. How many unique customers we've got, which is unique Alexa devices, not necessarily people using those, because it doesn't distinguish between two people on the same device, and which of our intents or actions are popular. So we could determine that everyone loves the horoscopes and no one cares about the mascots or the animals. This is obviously great, and it's kind of out of the box, and you get this for free. Where it's not great is if you were to then add another voice channel and you wanted to answer marketing questions like, how are we doing across voice as an entirety, or how does behavior differ on Google Home versus Siri versus the Alexa? That's actually something that we're going to look at with a partner of ours called Dashbot in the next webinar in this series. They provide an all-encompassing voice and chatbot analytics solution that would be able to give you the answers to those questions over multiple channels.
Wonderful. Perfect. So with that being said, as Simon already alluded to, we would love to see you at the next webinar, part 3, the final installment of this series. We're going to be partnering up with Dashbot and focusing on how to optimize voice technology with conversational analytics. This is going to be more of a marketing-focused webinar in the series. So the first one, more marketing, this one, more technical. Final one, more marketing. But Simon is also going to walk through how to integrate Dashbot so that you're able to see those cross-platform analytics. Thank you, everybody, for attending, and we hope to see you at the next webinar.